Hey everybody, I think we're almost ready, a few more people trickling in, but let's get started. I'm Roland, I'm a product manager at Databricks, and I'm super excited to talk about Databricks Workflows today, our orchestration tool. Many of the things that I'll talk about today are things that we're still iterating on, so thanks to your feedback, things might change and will still further improve. So just a quick show of hands, who of you are using Databricks Workflows? All right, wow, that's awesome. Thank you guys, really love it. Who of you has not yet used Workflows or using another orchestrator or on the Lakehouse? Okay, a few, so a few new folks. So what I'll talk about is then a quick overview of Databricks Workflows, just for the new folks. Many of you will already know this, but maybe a good refresher. Then we'll talk about all the things that we have launched over the last year, just a quick highlight reel. And then we'll talk about the things that we'll do next year, and we'll end with a small demo. All right, Databricks Workflows has actually been around for quite some time. It wasn't even called Workflows at the beginning. In 2015, we launched orchestration on the Databricks Lakehouse. It was a cron-based scheduler, and you could only run individual notebooks at the time. And Ali, our CEO himself, wrote that blog post when it was launched. 2016, we built notebook workflows, so you could start chaining notebooks together in a sequence. 2020, we developed a UI that allows you to build dependencies and DAGs between those different tasks of a job. We invested a lot of time in reliability and monitoring of those tasks, so you can be sure what's going on and get up running again if you need to. Then in 2020, we built the best Lakehouse orchestrator by integrating with all the different task types available in the Lakehouse. For example, you can then run DB-SQL tasks, can do alerts, refresh dashboards, many different activities across the whole Lakehouse that you can do. Or for example, DBT task types. We've also built streaming support for continuously refreshing data. And we've built cluster reuse, which reduces the time it takes for the whole job to run. You don't always have to start up a new cluster for every task. And that reduces time and cost. And then 2023, we've invested a lot of energy in serverless, in making the performance of workflows and the ease of use even better. 2024 is going to be the year of AI-powered and unified ETL. So look at that keynote tomorrow. So why did we even build Databricks Workflows? Well, with modern data engineering, you also need an orchestrator that supports those modern data engineering needs. So one of the things that you can see on this graph is the many different use cases, ETL, BI dashboards, machine learning and model training, but also real-time applications like streaming. All of these require data pipelines and data flows. Many of those are fairly complex and interdependent. So having an understanding and an overview of how these work together can become really cumbersome and complex. Also, we saw that many organizations, more than 65%, use then more than 10 tools to string their different data and AI needs together in order to make data engineering and intelligence work. And that, of course, also reduces how much these tools can interact with each other. And we see that with their orchestration in particular. There's many tools that can orchestrate on the Databricks Lakehouse. And in fact, we have the Jobs API, which makes it really easy to integrate with Databricks. So we're very happy to support that API for all of those use cases and for all of those orchestrators. Yet, when it's a separate tool, it comes with shortcomings. It's often hard to use for practitioners. For example, managing all of the infrastructure around it, developing in Python. It's difficult to understand root causes when your code, your compute, and your orchestration live in different places. It's also complex to maintain the architecture, because now you have separate tools, separate infrastructure to maintain that. Now you still have to manage to maintain that connection all the time, no matter what upgrades and updates you do on each of the tools. So this is why we've built Databricks Workflows, unified orchestration for data analytics and AI on the Lakehouse platform. It's simple authoring, so anybody can use this. It's actionable insights to make sure your workloads are running reliably and all the time, and it's proven reliability because it's a fully managed service. So what does that mean in a little bit more detail? So simple authoring means any practitioner in the UI, and we'll see that in the demo in a bit, can click together a workflow with dependencies with each other. And they don't need to know what instance types are. They don't need to know what even what they're actually doing under the hood. It also means, though, that people who are data engineers and who have a deep understanding can also use data engineering best practices. They can develop those Databricks workflows in the comfort of their IDE. And we support them with versioning and with CI/CD tools. We also provide actionable insights. We give you real-time monitoring, how your workloads are running, which ones are running, which ones are failing. We provide an overview over the health of your job and your workspace overall. We have proven reliability with 99.95% uptime. That means we're as good as any other cloud platform, and you don't need to manage any of that infrastructure. So this is why more than 10,000 customers now trust Databricks Workflows for their workloads. And here's just a few examples of those. We're also launching more than 25 million VMs per day. We're the largest requester of VMs on at least one of the large cloud platforms. Keep that number in mind, it's going to become important for serverless. And so as I mentioned, 99.95% uptime. Because now all of these tools are unified in the Lakehouse platform, that means that, as you can see in the examples here, people are seeing improved collaboration because it's all in the same tool. They see a significant reduction in cost and a significant improvement in time of processing their data. So that was just a quick overview of what we want to achieve with Databricks Workflows and the idea behind it and a little bit of the history. Now, over the last year, since we met last year, we've launched more than 17 new features. And so I just want to highlight a few of those. So, more triggers. So obviously you can trigger your Databricks workflow when a certain time arrives, and you can set that up with a schedule. But most of you depend on data. You want to be as close to when the new data arrives, then you want to run your workload. And so we've built data triggers. There's two types of data triggers. One is trigger when a table has updated, and you can actually specify multiple tables. You can see this here on the right side. Here I have 3 tables specified. And if all of those tables have updated, both table 1, 2, and 3, all of them have updated, only then we trigger the job. And this does not require any compute on your end. We'll do this all in our control plane. We'll observe the tables, and only when it's ready, we spin up the compute for you. We do the same thing for file arrival triggers. And file arrival triggers have been around, and they had a limit on the number of files that they can observe. And I'm super glad to announce that that limit is going to be gone very soon. So you can have basically unlimited amounts of files that you can observe in a location. You can also trigger one job from another job. So trigger your downstream jobs. So we've invested a lot in triggering and allowing you to run your jobs only when you need to, when new data has arrived. All right. We've also integrated even deeper with SQL. So you can now reference the result of a SQL task in the next task. So you can use it, for example, to parameterize what is happening next. You can see this on the right side here. So you can see here the first task queries the locations of my stores, for example. And then in the next task, which is a for loop, it loops over all of those store locations, and the aggregation location notebook here aggregates the revenue of that specific store location. And we also now support multi-SQL statements. So now SQL is fully integrated, including task values that can be propagated from task to task. Overall, we made Databricks Workflows significantly faster and easier. You can now use up to 1,000 tasks per job. We have improved the defaults for clusters. So when you click in the notebook on schedule, we'll automatically pick up what is the right cluster configuration to maximize compatibility with what you've been running in the notebook. You can easily exchange messages across the tasks call those task values. And we've simplified the UI for this. So here on the right side, you can see it auto-completes all of the different values that you have available within that job. We've also integrated Assistant even further, and you'll see more in a few slides about that. But just one example here. When you want to specify the cron schedule of a job, you could say every month on the 10th and the 20th, and then it's going to suggest to you, powered by AI, how that cron syntax looks like, making it even easier for every person to use this. And then in terms of making it also easier to find what you're actually looking for, we've introduced filtering by tags, for example. I'm only interested in the jobs that are from the finance team, so I can filter here by that tag, and then I only see those that have the finance tag. We also introduced favorite jobs, making it even easier to find the ones that you're currently working on, for example. We've introduced descriptions. That means if some of your colleagues need to go into a job, fix something, or need to understand what's going on there, then you can leave a description for them so that that ops team that might have to debug it at the middle of the night can get right started. Here's more about the assistant. So you might be familiar with the assistant already in the context of the notebook. So in the context of the notebook, it helps you debug, it helps you generate the code. And we've also integrated it here on the right side in the Databricks workflow as well. You can see the notebook on the left, there was an error, so it didn't successfully run. And then I can now click on Fix Error, and it invokes the assistant on the right side, and it gives me a suggestion of what's going on, what's wrong, and how to fix my code. So the AI assistant is now seamlessly integrated between notebooks and Databricks workflows as well. So that makes your experience much easier in debugging. You only need to run when something goes wrong, what has actually gone wrong. So no need to rerun successful tasks. And that's been around for more than a year now, but now we made it even easier to select those things that you want to run. So here you could select then everything downstream, for example, from a task that has failed, or everything upstream. You can also unselect certain tasks that might have failed, but that you don't need to rerun. Or select a task, even if it has completed successfully, you might want to rerun it because new data has arrived, or because actually not a lot of data was there yet and you want to capture all of the new data. So this now makes it even easier to rerun and only process the data that you actually need to process when something has gone wrong. We also make it a lot easier to optimize for price and performance. So we've introduced a timeline view, and you can see this on the right side here. Typically, you would see the graph, which is the DAG, with all of the dependencies of your workload. And here on the right side, you can see that now there's a timeline. Filtering and reporting is one of the tasks in this DAG, and ingestion is another task. You can see when it started, when it ended, it's red because it has failed. And then we started a retry right after it. You can see ingestion started in parallel to this. And the thing underneath here is that we've also now integrated query profiles. So now you can see which queries were actually running as part of the duration of this task. And you can see in which sequence they ran. This allows you not only to pinpoint issues when something goes wrong in terms of failure, but it also allows you to pinpoint what are the things that are causing the duration or the delay in my processing. And then you can hone in on those much faster. We're also introduced tracking for streaming lag, making it easier for you to identify issues in your stream as they come up. And we have alerting on timeouts when your job is running late. The alerting that you can get is now not only via emails, we've introduced webhooks, and we've expanded the breadth of native webhook integrations with now Microsoft, Teams, PagerDuty, and Slack. Many of you have been asking, how can I identify how much a job costs? How are the trends over time? What's the most expensive job? And so I'm super happy to announce that we now have system tables, which not only give you cost, but also a lot of detailed specifications on the run of a specific job. So this allows you to say, hey, I want to see how the evolution of that job is over time. The run durations over, let's say, 3 months. What happens when there's Black Friday? And so system tables allows you to pull in all of that data and do customizable analytics on top of it. We've also introduced templatized dashboards that make it super easy to download and with 2 clicks install in your workspace, and then get one of those dashboards that Jacek, one of our engineers, has built, and that allows you then to also see the top metrics, cost over time, the top jobs by spend, the top spenders by spend in one go. And you can further customize that to your specific needs. I'm also happy to announce that we're soon having an in-UI integrated dashboard for budget monitoring and alerting. So you don't even have to import that dashboard anymore. All right, and you can now do anything on Databricks with Python code. So PyDabs allows you to have a Python SDK to develop a workflow, for example. You can deploy this with Terraform or with Dabs. You can run this as a service principal. So this means you can now deploy things into production, into your production workspace. You can develop them in the comfort of your IDE and compare the changes before and after, before you deploy, and collaborate with your colleagues on it. And by the way, speaking of code, you can now also switch forth and back between a visual representation of the DAG and the job and the code, which makes it much easier to do, for example, bulk operations. I'm super happy to also announce that we have ingestion connectors now. So that's super cool. Many of the DAGs, many of the workflows that you're running start with getting data in from somewhere. And so this is just a quick highlight about ingestion connectors. Please check out the breakout session by Elise tomorrow at 11:20. Yeah. So ingestion connectors, what does it do? It's a simple and low maintenance way to ingest data from specific sources. We've unified that in the lakehouse, meaning that it's secure. We're monitoring the health of your pipelines, and you know that the ingestion is living in the workspace that you're familiar with. So there's end-to-end monitoring and full integration. It's also super efficient because we do this at a low cost and better performance and scalability. So there's no headaches about thinking about, does this API that I'm ingesting data from change? We'll take care of that for you. We'll keep those up to date. And this is now in private preview for Salesforce, Workday, and SQL, and many more connections are coming. So that was just the things that we've done last year until today. So what are we going to do next year? Well, first of all, we're not done with triggering yet. So more triggers and control flow options are coming. So for each, we can iterate over a specific task or notebook, changing the parameters. Has been super popular. But we've heard you all. There's been the ask for, can I iterate over not just one task, but I want multiple tasks. I want a group of tasks. And so that's what we'll be introducing. And this is what you can see here on the right side. And in fact, many of you have also asked for, hey, can I group semantically similar tasks somewhat together to make it easier to understand my DAG? And those two features are coming together here on the right side. And you can see that this is a task group. This is multiple tasks in a dependency graph that are grouped together and collapsed now. And there's an iteration around them. We'll also be working on periodic triggers, so like run once a week or an hour or a day. And we'll have multiple triggers per job. I've heard several asks, even today, from one of our customers. Hey, I want to run on a certain day, every day, except for these banking holidays, let's say, right? And so things like that is something that we'll be looking into. One of the most exciting changes here is serverless and Unity catalog that is coming. Yet many of the workloads that you're running might not be fully compatible yet. And so understanding when to run them and how to run them and what to change to make them compatible has been really hard. So I'm super happy to also say that we'll soon have compatibility checks. When you pick the compute, we'll automatically check, is this notebook compatible with that code? And we'll give you a warning. And then with the power of the Databricks Assistant, we can also help you, like what you see here below, suggest new code or changes to the code that will make that notebook compatible. Many of you might be already familiar with the operational dashboard that we have for jobs specifically. So you can look at how is a job running, which jobs are running, how many jobs are running over time, what are the failures, which failures are most common. And I'm super happy to say that we're working on integrating that across all of data engineering for a single operational view across those assets, across the ingestion connectors that we talked about, across Delta Live tables, and across workflows. So it means all of these assets you'll be able to monitor in one place, check what's going on, and it will not only be success of execution and failure of execution, we'll also be monitoring the health of the underlying data, which is ultimately what you really care about. So we'll be able to detect any of those issues with Lakehouse Monitor, for example, for data quality. You'll be able to see all of those assets, and we'll have anomaly detection to see if something is unusual, because we've seen the previous runs of this job, right? So we can see if they deviate significantly. And of course, you'll be able to filter down to your team and to the relevant jobs that are interesting for you or to the relevant assets. So that becomes a single to-do list for your operational team to check, which jobs do I need to follow up on. Then I'm also super excited to talk about serverless compute. So remember that we're launching 25 million VMs a day. So that's a lot of VMs. We also have the founders of Spark in the company, right? And so there's a lot of expertise that we can bring together here to fully manage infrastructure for you with serverless compute. A lot of data on, how are those 25 million VMs running, a lot of expertise on Spark, and a lot of expertise on managing infrastructure. And bringing that together as serverless compute means that we provide compute that is simple and fast, literally no knobs. You'll see that in a bit. It's fast startup because we have a warm pool of machines that are ready to go for you, and any practitioner can use it. So you no longer need to know, what an instance type is, what a VM is even. It just becomes a compute layer that's super elastic, responding to anything that you throw at it. It's very efficient because it's a fully managed service. Again, you don't have to worry about any of the infrastructure management. We'll take care of that for you. And it's versionless. I've heard somebody say that they spend up to 40% of the year of their available time on upgrading to new DBRs. So that's going to be gone. So I'm super excited about that. We'll auto-upgrade you to the latest DBRs. We'll do testing for you if your code is compatible. And then deploy all of those improvements and performance improvements that come with these new DBRs. You're only paying for what you're using in serverless. So that means utilization becomes a Databricks problem, right? You just run it, and we'll charge you for the vCPUs that you utilized. But if we deployed more, you're not getting charged for those that are not deployed or that you're not using. And so now you're asking yourselves, okay, but if I can no longer determine how many workers are being deployed, how do I manage cost? You're no longer managing cost by limiting and throttling your analysts or your team members, by limiting the number of workers, but instead by directly saying, hey, I want a cost cap on Roland. Roland shouldn't be spending more than X per day. And then you'll be getting alerting and all of the dashboards that I've showed you. So strong cost governance. It's also reliable, secure by default, and we're stable with smart failovers. So this means we have a warm pool of machines, and that already shields you from quite a bit of cloud outages, for example, because it basically acts as a buffer. But we can be smarter because you're now no longer saying, I want exactly that instance type. We can fail over to other instance types for you. So that means your workload that would have failed in the middle of the night and paged you, we will now automatically run on another instance type that's compatible. And that means success for your workload and no sleepless night. So all of this is built on the serverless compute platform that you're familiar with in Databricks SQL, where it is generally available for production. And currently, we're also in public preview, which also means production readiness, on workflows, notebooks, and Delta Live tables. So why does this matter for you, and why should you care? Well, with serverless compute, you stop spending time on setting up networking, defining IP ranges, security and compliance, on managing efficiency. Is this cluster too large? Am I wasting money? Is it going to fail in 2 weeks because the data volume is going to grow? Right? That question becomes a Databricks question. And on upgrading DBRs. Stop spending time on those. So how does serverless work? Well, you've got all of your users in the different workspaces. We have a warm pool of machines ready for you to go. And then when one of those users in one of those workspaces submits a query, we allocate free instances from that warm pool of machines that is by the region, and we allocate that to you and only to you in that specific workspace. And that cluster that forms from it is now going to do the query and run the job that you wanted to do. It's going to access your data. And once it's done, we basically throw away that VM, right? We give it back to the cloud provider, it gets completely wiped. Now, how can we do this efficiently, right? Remember, it's 25 million VMs per day. That's a big number. Most of those VMs are scheduled through us. So that means we know when they're supposed to run. We have seen the previous runs. So that means we can learn, predict, and pre-provision those very efficiently. And so that warm pool amortizes across all customers in that region. And I'm super happy to also say that soon, all of the DB SQL regions will be enabled by this. So as serverless is rolling out. So a few key technologies, I'm going to go fairly quickly over those. We have an AI-managed warm pool of machines. We have an enhanced horizontal autoscaler that builds on top of that warm pool. So we've built that from scratch to make things even more performant. We have versionless. We have, lake guard, which means we can secure the user code from each other in Spark and on top of Unity Catalog and Spark Connect. We have environment caching. That means you no longer need to download and install the libraries. We cache them for you, and so they'll be ready to go within seconds. We also have smart failovers. We provide query insights and lineage to all of your workloads, and soon we'll also have automatic vertical scaling, for example, for OOMs, for out-of-memory issues. So that means serverless compute on Databricks and in Workflows is a fully managed service, no worries about infrastructure, and it's automatically getting better every time you run it. Here's how this looked like in Workflows before serverless. I don't expect you to be able to read this, right? This was the clusters form. There's way too many settings in there, and we just got rid of all of them. So this is how it looks like now. This is your job, and you can see down below, you just select serverless compute. There's no other configuration that you need to select. And then specifically for workflows, there's different execution goals. So remember, with serverless, we want to abstract the question of infrastructure to a question of what are your goals, what are your business goals? Instead of saying which instance types you want, tell us like if you want it fast or if you want it cheap, right? And this is the idea here with these execution goals. So right now, what we have in production is performance optimized, which means you're getting less than 60 seconds startup time, which is better than an instance pool. There's other modes coming as well. Right? So a development mode where you say, I want to develop a job, for example, in my local IDE, and I want to submit something and see how this runs. I don't want to wait a minute. I mean, that's barely enough time to get a coffee. So in development mode, you get down to 5 seconds, which is the same as you get for serverless interactive, which is down to 5 seconds. And then there's also going to be a cost-optimized mode, which allows variable timing, where you say like, I don't care if this finishes at 5 a.m. or at 7 a.m., but it's got to be done when the people get into the office in the morning so that they see the dashboard refreshed. And that gives us the freedom to shift that workload around in time. And that also means we can optimize the footprint of it and reduce the cost for you. And of course, very important for workflows in particular, it's very stable, particularly with smart failovers, versionless, so it's constantly improving with new DBRs. And we have environment caching, so no longer are you suffering from the installation times. All right, when should you use serverless? Anytime you do interactive Python workloads, SQL, serverless is very clearly, you should get started with that. Obviously, everything here is built on Unity Catalog and Lake Guard, so your workloads need to be compatible with that. So also for new jobs and existing jobs, when they're compatible with Unity Catalog, shared access mode, then you can use serverless. Well, it's very straightforward. You will benefit even more if your jobs are time sensitive. So you're looking for high performance, you're looking for fast startup, or if you're having streaming workloads. It's also now fully supported in serverless workloads. And because of the warm pool of machines, because we start up much faster, that is, of course, very interesting right now, particularly for the performance optimized mode. If you're having instance pools or all-purpose compute, look at serverless as well, because it's going to be cheaper than instance pools, and it's going to be actually faster too. because we go down to below a minute. Well, when should you wait a little bit? Maybe later this year. If you're looking for that cost-optimized mode or that development mode, or if you need enforceability of team-level attribution, means like if you want to attribute cost to certain teams, maybe for internal chargebacks, then you might want to wait because while you can do that, you're relying on the tagging of the individual team members. You cannot enforce the tags yet, but that is coming. If you need detailed internet access controls, ML runtimes, or GPUs, those are also coming a little bit later. All right, with that said, I'm now super happy to announce that serverless compute for notebooks, workflows, and DLT is generally available and rolling out over the next couple of weeks. So super excited about that, and it's going to be available in all DB-SQL regions. There's a specific breakout session on this at 4 today, so please check out my colleague's John talk on this. All right, with that said, should we do it Casey style and do a live demo? Let's see. Let's give that a shot. All right, quick demo. So what I'll show you is that I need to log back in. So far to live demos. I'm already regretting my choice. All right, let's quickly go here to the jobs. I just want to quickly show you how easy it is to actually create a job. So you can find workflows here on the left side nav. And then it's as easy as like click create a job. This is our DICE demo. So you're going to name it that way. And then this is our first task. This is the canvas where we create the tasks. So this is task 1. So I can do the task specifications down here. There's many different types of tasks. So I just have by default, the most popular type of task is a notebook. This is what I'm seeing here, but there's also Python script, wheel, SQL, Delta Live tables, many different DBT jars. And there's also tasks that are, for example, for control flow, for conditionals, if-else condition, or for each, the loop that we were talking about earlier. There's also data quality. So you can check the data quality after a certain part of ETL has been done. You want to check, did I actually process the right amount of data? Is it enough rows? Are there deviations, etc.? Right? So that's basically Lakehouse Monitor. So, but we want to just create a notebook. And so I'm going to select the path from my workspace and, let's ingest some clicks. So I'm just going to use that task. This is now running here. So I can select that. And you can see that there's other dependent libraries that I can install. I can set up retries. And now I'm just going to create that task. All right, first task created, first job created. That's how easy it is. Maybe let's add a second one to that. But before we do that, you can see that there's a few more parameters on the right side. We talked about the descriptions. Here's version control with Git. And we also have schedules and triggers. Let's take a look at that. So here, no trigger selected yet. So this would never run unless you click Run Now. But obviously, schedule is the most popular one. There's a simple way to schedule, say once a day. But then you can also specify the time. And you can also express that in cron syntax. And you can use the power of AI to help you configure that cron syntax. And then there's the data triggers, the ones that we talked about. You really want to run that when new data has arrived, then you want to process it. Not sooner, not later, and you don't want to wait. So that's why we have file arrival triggers, which allows you to enter a location in blob storage. And we will monitor that for you and only spin up the compute and the job once new data and new files have arrived. And the same thing for table updates. So you can specify multiple tables here that we will monitor for you. And if all of those have updated, only when all of them are done, we will trigger it. Or you can also say, if any of them have updated, then we will trigger the job. So I'm going to cancel out for here now and just add another task so you can get a feel for the dependency as well. So this would be task 2. Let's do a notebook task again. And now we've ingested some clicks. We will want to build some features. Okay. So now you can see that the depends on is on task 1 by default, but of course you can change this and chain together any arbitrary kind of DAG that you wish. And you can also see here that the run on dependency has multiple options. The default is by success. So that means only if all of the upstream tasks have succeeded, you're going to run this task. But there's other ways of dependencies that you can select as well. One other one is, for example, at least one has failed. So if you need to clean up something, clean up some tables, if something in the middle has failed, and you might want to restart that process from the scratch, then you might have to do some cleanup. So that could be the at least one has failed that you might want to select here, and then you can click Create Task. All right, so now we have our little small DAG. Let me show you something a little bit larger. So here I've prepared a slightly larger DAG for you that shows you a little bit more what can be going on here. So at the beginning, this DAG produces product recommendations. So first of all, we need to understand what products, which consumers have actually used and bought. So for that, I'm going to iterate over a couple of tables and ingest those. So we have an iteration task here, and I can pull this up a little bit in the definition. And these are the table names. It's just going to iterate over those table names. And it's going to run the notebook task that's within with those as parameters. So now I'm just going to ingest data from all of those tables. That's my bronze layer, basically. Then I have a silver layer, 3 notebooks. They're all running serverless. Oh, copying this. Okay. So they're all running on serverless compute. They're actually running on a classic cluster, but okay. There we go. And you can run all of these on serverless compute. And that allows you to run these super fast, not having to worry about cluster reuse, startup times, etc. So then these 3 clean up the individual tables that we've ingested. And then we've got a gold layer, and that produces our golden tables. After that, we're going to send a SQL report to the team to understand, hey, what does our business look like? How many people have bought what? And how much is our revenue, maybe? We can also train a machine learning model. So this is this task. First, before we train that machine learning model, we want to see, has the existing model drifted? And we're going to check that in this task here, and then we'll publish the results of how our machine learning model is still performing. Should something go wrong here, we have this task. And this task allows you to check, has something gone wrong, then I need to clean up my tables. And then sometimes you need to retrain your model. So if it's Sunday, in this simple example, but you could also parameterize this on drift parameters or anything else for your model. If it's Sunday, then we'll retrain the model, which is this task. And then we can also, with these other 2 tasks here, we can basically update a serverless inference endpoint, and we can run batch inference. So that's a little bit more complex a model, and I've run this model a few times before. So if we look at the runs, I'm going to discard the changes. You can see here an overview of all of the runs that have been happening for this model. I'm just going to go down here. Some are even going on here. That doesn't look too great. Some of these are failing. I've set this up to fail a few times. So let's take a look at that. What I can see here in this view, what we call the matrix view, is every column is a specific run of a job. And every row here is a task in that job. On top here, you can see, in these bar charts, how long it has been taking for this job to run. And you can see there's this dotted red line. That's the red line when we say, hey, give me a warning, this thing is running late. So that's when you would be getting an alert. But let's take a look at this one here. This one has failed. So I can go in here, I can see the DAG, and I can see old aggregation layer has failed. And I can now go in and repair this run. So automatically it selects all of the things from the failure and downwards, but I can also select and unselect certain things. So for example, the cleanup task, I don't need to run that anymore. But maybe I know that it was an issue here in my silver layer. So let me rerun this specific task as well. So I can just click on repair, and that's going to trigger a run now. I can also specify new parameters or changes in parameters as I repair this. I can also look at the timeline. So let's actually quickly go back to the job view, and then we pick another run. Let's take this one, for example. So this one has succeeded. I can view the DAG again, everything looks fine. I can also look at the timeline. What are the things that have been taking long here? Ooh, and I'm actually realizing something here. I can see in this overview, this task, the gold aggregation, has been taking pretty long. And the reason why it's been taking long is because in its first iteration, it has actually failed. And then because retries are configured, Databricks has automatically retried and ultimately succeeded the job. But the reason why it was long is because, hey, there was a failure and we had to recover from it. So maybe that's something I can dig deeper into. All right, so that concludes somewhat the demo. High-level overview. And there's more things to explore. So I want to highly recommend those following sessions. There's serverless compute today at 4 p.m. Please check that out. A lot more detail on the things that I've just been talking about with serverless, but not only for workflows, but also for notebooks and Delta Live tables. The ingestion connectors by Elise on Thursday. And then super popular, I think like for the third time repeated in this Data and AI Summit, Prashant's session on practical how-to-dos and demos on Databricks Workflows. So super highly recommended. There's another session on this tomorrow, maybe two, if we can get it in. So check out Prashant's session here. And then tomorrow's keynote I'm particularly excited about. It's going to talk about AI and unified data engineering. So that's going to be very, very exciting.